Okay, welcome to our astronomy unit. We're going to start off with the intro to stars. What we want to do is we want to get some basics on some different things to help us understand the stars and to understand astronomy. Okay, so radiation, we've all heard of radiation in some form or another, but radiation, what it is, it's energy that travels through space in the form of waves. Okay, we get radiation from the sun, and it comes to us from 93 million miles away. And because there's no molecules out in space for it to travel through, it travels through these waves. So what we need to know is we need to know the different parts of a wave. And there's what's called crests and troughs. The crest is the high point of a wave, and a trough is the low point. Okay? I always think of the crest as being maybe the top of a wave, like a surfer would ride a wave, and the trough being like a hole in the ground, or maybe a trough like a pig would eat out of. So make sure that you're drawing this in your notes, drawing the wave, labeling the crest and the trough. Okay, so on your diagram, you're going to want to also notice one other thing that's called the wavelength. The wavelength is the distance that's measured from crest to crest or from trough to trough. Okay, so what you do is you measure from one point, the exact point on one crest, to the exact point on the next point, and that gives you one wavelength. You could also measure from the trough to the trough. That would be a wavelength 2. It's just easiest to go from crest to crest. So using this idea of wavelengths, we use that size of the wavelength to determine the type of energy. And we can see that in what's called this electromagnetic spectrum. The electromagnetic spectrum is kind of a simplified way to look at all types of energy. We got over here on this side, we have some really short waves called gamma rays. And over here, we have some radio waves that are very long, 10 to the 4th power. These are really long waves. And then in here in the middle, we have the visible light that we can see. We can't see anything else. We can't see FM radio, we can't see TV waves or X-rays. We can only see this small part in here that's called the visible light spectrum. Okay, so what does this have to do with stars and astronomy? Well, stars give off electromagnetic radiation in several forms. Some of it we can see. We can see a star, we can see visible light, and it also gives off radio waves and X-rays. Now remember that radiation is the only type of energy that can travel through space. And radiation travels at the speed of light very, very fast. It travels at 300,000 kilometers per second. Okay? And if you were to think about how fast that actually is, it could go around the Earth 7.5 times in 1 second. So, in the time it takes to blink or to snap your fingers, it could go around, that energy could go around the Earth 7.5 times. Okay, so frequency is the number of waves that happen per second. We measure that in the unit called hertz. So, shorter wavelengths produce a higher frequency, meaning more waves per second. Okay, if you look at that word frequency, it's how frequent the wave happens. So in something with a short frequency, the waves are going to be happening fairly rapidly. Higher frequency also creates more energy. Okay, so if we look at a couple examples here, if we have a wave here and a wave here, which one has the higher frequency? Well, this one here is going to have the higher frequency. These waves are happening more rapidly than these waves here. Okay, so this is going to create more energy here than over on this side. Okay, so this one would have a high frequency, this would have a low frequency. It's kind of like a heartbeat, where if your heart is beating fast, it's going more frequently, whereas if it was a low frequency, it wouldn't be producing as much energy, and it would have a low frequency. Okay, so looking at the electromagnetic spectrum, we notice that the arrangement of energy waves goes from longest to the shortest. Over here, having our long waves, and over here, having our very short waves. Okay, so we want to label a few things on here. We want to label over here where the long wavelengths are. And over here we have the short waves. Okay, now just by looking at our waves, we can tell about the frequency too. Here, where we have the long wavelengths, we can tell that this is a low frequency because they're not happening as often. And we can also make a prediction about the energy. If it's not happening very frequently, we can assume that there's less energy. We're going to have low energy here. Whereas on the other side, we have a much higher frequency. And therefore, since it's happening very frequently, we're going to have much higher energy. Okay, now we can also make another assumption, is that on the left side, if we have low frequency and low energy, we can assume that the temperature is also going to be low. And on the right side, the temperature would be much higher. Okay, high energy, high frequency is going to create higher temperatures. Okay, now we just have to add in what the types of energy are. There's 7 different types of energy. Starting with the long wavelengths over here, we have radio waves. And then we also have microwaves. Okay, after that we have infrared. And right here in the middle is the visible spectrum. And that we can see here, the colors of the rainbow, those are the colors that we can see. We can't see a radio wave or a microwave or an infrared wave, but we can see this visible portion right here. Okay, after that we have beyond the purple, or the ultraviolet. After that we have X-rays. X-rays have a lot of energy. Okay, then we also have gamma rays. And our atmosphere mostly absorbs these. You see these mostly out in space. Okay, so what about the uses of these types of radiation? Radio waves we've been using for years, for music, communication. We also use it for TV, for cell phones. Okay, the microwave, probably the best invention ever, is obviously used to reheat food. Okay, and it's also used for radar. The way it reheats our food is it causes the water molecules to vibrate very fast, and that causes your food to warm up. Infrared energy. Infrared energy is mostly used mostly for night vision. Okay, or night goggles. You can see on some war movies or some of those crime shows that they use the night vision goggles. It detects the heat, things that we can't see. And then there's the visible spectrum. Obviously, that is the part of the spectrum that we can see. So ultraviolet radiation is part of sunlight. Don't want too much ultraviolet radiation, gives you skin cancer. Black lights are also ultraviolet lights. X-rays can go through solid objects. Therefore, they're very useful for medical purposes and for security at airports. Gamma radiation is mostly absorbed by the Earth's atmosphere. But that high radiation can be used for sterilizing objects and for medical imaging as well. So the electromagnetic spectrum allows us to look at all the different types of radiation from longest wavelength to shortest wavelength. And by looking at that, we can determine the different types of energy that it has and its frequency, and we can also determine its temperature by its wavelength. Okay, so now you're going to want to go on to the second video, go on to part 2.